Okay, in this supplemental video, we'll be talking more about units, and specifically how to manipulate them in this class. To review, in the SI units, there are prefixes that will allow you to reduce values that you get as your answer. And to start, there is giga, which is abbreviated big G, and it equals to 10 to the 9th. And that could be gigameters, giganewtons, which will probably be what we'll be using in this class, giganewtons. And there's mega, which is abbreviated as big M, and that is 10 to the 6th power. And we will probably be using meganewtons in this class. And the last one that's also most common is a kilo. That's abbreviated by a K. Sometimes it's little, sometimes it's big. It doesn't matter too much if it's capitalized. And that is 10 to the 3rd power. And then lastly, we will be using in this class milli, which is a smaller unit and is abbreviated little m. That's typically the little m to distinguish between the big M from mega. And that is 10 to the negative 3 power. And specifically, we'll be using millimeters in this class, very, very likely. In the US customary units, pounds will become kips. So a kip is equal to 1,000 pounds. And particularly what's going to happen in this class is you may get an answer at the end of a problem. That is, for example, 13,452 point something. Your calculator will tell you this. And you've been working in newtons. The problem statement gave you newtons to work with, and you did all your math, and you came up with this answer in your calculator. But there will be quizzes and homeworks or exams that ask to specifically write the answer in kilonewtons, or maybe it might even be meganewtons. But what this would do, or what you would do with this number, is then rewrite this number as 13.4. You could round, you could to 0.5 if you like. It doesn't matter too much for me. But the important thing is to converting this to 13.14 kilonewtons. And I could actually even specify as the answer to write this in meganewtons. And this answer in meganewtons would be 0.0134 meganewtons. You see, I had to move the decimal place over 3 additional times to get to the 10th to the 6th power to get meganewtons. I likely won't do this in the exam because you typically at your workplace will not be required to specify units like this. It doesn't look good to write 0.0134 meganewtons, especially because it's easy to accidentally put the decimal point in the wrong spot. So typically you will write units like in kilonewtons. Or if your answer was significantly larger, like for example, maybe the answer you got in your calculator was 534 million, 215,134 remaining, and maybe you have some 0.9 remaining. And we're working in newtons. If you started your problem in newtons and you receive this answer in your calculator, then you will convert this to 534 meganewtons. You see that we completely bypassed the kilonewtons because the number was so large. So we're going to specify this in 53.4 meganewtons. Again, if you want to write 534.2 or 0.21, that doesn't matter too much to me. in this class, but the point is to be able to convert this. Okay, now let's talk about converting meters and millimeters. You might have an answer like this that pops out as 0.134 meters if you were originally working in meters. You would need to convert this to millimeters if specified by the problem statement. And because millimeters is times 10 to the negative 3, we move the decimal point over 3 to the right. So that would be 134 millimeters. Remember, millimeters are smaller than a meter. We might also have an issue where either the problem starts this way or you end up with an answer in meters. So you might have 15 meters. And you will need to possibly use millimeters in your work. Well, this is even easier. 15 millimeters is you just write in what 10 to the power it is. 15 times 10 to the third power millimeters. You can also do the math and write this out individually and add all the additional zeros if you like, which would just be a lot harder or longer to write, and that would be 15,000 millimeters. Both work and both can be acceptable as an answer in this class. Now there might be an issue in this class where you have to multiply two lengths together, and the start of the problem might be in millimeters, might be in meters, but eventually you might have to convert it back and forth. So let's take an example of I give you a length of 2 meters, and you need to multiply it by another length of 3 meters. Well, you're going to pop out with square meters at the end of this. 2 times 3 is 6, and your units are going to be 6 meters squared. But you might have to continue doing some math, but to have consistent units, you might need to be working in millimeters squared. Well, you cannot just add times 10 to the third to this and have it equal millimeters squared. Okay, this doesn't work. We are using squared units now instead of just linear units now. So what you effectively need to do is add times 10 to the third twice. And adding times 10 to the third twice is just 10 to the 6th. So 6 times 10 to the 6th millimeters squared is the equivalent to 6 meters squared. Okay, it's very important to understand that you can't just add on the 10 to the third when you have square millimeters. And this continues if you need to work with volumes where you have meters to the third or millimeters to the third. You need to add an additional 10 to the third, which would make it times 10 to the ninth. We likely won't be dealing with that. We'll just be dealing with areas in this class. So it's important to know how to do this. Okay, now to go the other way, let's say that you were working in millimeters and you needed to go to meters into the square. So let's say you had a problem that was 2 millimeters times 4 millimeters. Well, then that would equal 8 millimeters squared. And you need your answer to be in meters squared. Well, to go the other way around, it's to the negative third power, and just like up here, you can't just add one single 10 to the negative 3 power, you need to do it twice. So 8 millimeters squared converts to 8 times 10 to the negative 6 meters squared. And of course, for both of these, you could pre-convert before you do your math, if that's easier for you. So before doing 2 millimeters times 3 millimeters, or 2 millimeters times 3 meters, you could convert that to 2 times 10 to the negative 3, or 3 times 10 to the negative 3, or vice versa for the 2 millimeters and the 4 millimeters. If that makes it easier for you, then your answer will automatically pop out in the units that you need. Both work, but these are just additional examples to help you with this class. Now we're going to talk about dealing with units of stress. and units of stress specifically in the SI units. So the units for stress, the SI units, is a Pascal, abbreviated PA. And a Pascal is the equivalent of 1 Newton over meter squared. It is not equal to 1 Newton over millimeter squared. So there's going to be times where the problem statement gives you the length and dimension of a situation in millimeters. Now if you just multiply those and get millimeters squared and then divide that into the force, that will not be a Pascal. You must convert this millimeters to millimeters squared to meters squared, and then divide that into the force to get Pascal. Now there are also going to be situations where the problem statement is in newtons and millimeters squared, just like I talked about. But there's a trick that I will use often in this class. And the trick is to take newtons and millimeters squared and have the answer become megapascals through basic conversion. So for example, you might end up with an answer of 25 newtons per millimeters squared. And I'm going to need to convert this. I'm going to need to convert the millimeter squared to meter squared to get Pascal. And to do that, or to get megapascals, I first need to multiply the kilonewtons by 1,000 newtons. So there's 1,000 newtons here in the denominator, which will cancel out to the newtons on the numerator over here. And the 1 kilonewton will remain on top. Now I need to get that into meganewtons. So 1 meganewton has 1,000 kilonewtons. Now that'll get me into meganewtons. Now I need to get the millimeters squared into meters squared. So I'll need to multiply by 1,000 millimeters over 1 meter. And I'll need to do this again. Let me see if I can zoom out. There we go. Because it's in square millimeters by 1 meter. Now, this entire problem will just cancel out. This 1,000 will get taken away from this 1,000. This 1,000 will get taken away from this 1,000. And now we're just multiplying by 1 over 1 over 1 over 1. And the answer just becomes 25 megapascals. So we started with 25 Newton over millimeter squared, which is not a Pascal. But we ended up with the same exact number. Both times it was 25 and 25. So whenever you start a problem with newtons and millimeters, you could continue to work in newtons and millimeters, and then at the end, whatever your number is, your magnitude, that just automatically becomes megapascals. It is a trick based off of the conversion process. You have 1,000 here, 1,000 here, 1,000 up here, and 1,000 up here, which all cancel out to just give you the same exact number, but the conversion process just pops out megapascals. So if you start with the newtons and millimeters, you will just end up in megapascals without having to do any conversion, but you're actually doing conversion. So this is a good trick and tool to know in this class. The last thing I want to talk about is using consistent units in your problem solving. You may have a problem that has an answer of, say, 9 kilopascals. And you're asked to determine what the force is given some area, or something similar to this. We're going to have to multiply this by an area. So the question might be, what is the force if the area is equal to, say, 3 millimeters squared? Well, to get a force from stress, you just multiply the area times the stress to get the force. But you'll see that these are consistent units. To help visualize this better, I'll write 9 kilopascals out in its full units. 9 kilopascals is also equal to 9 kilonewtons over meters squared, because remember a pascal is a newton over meters squared. And so if I would just take the numbers provided, I would take the 9 kilonewtons over meters squared and multiply it by the area of 3 millimeters squared. Well, that is not consistent units. This value here is in meters squared, and this is in millimeters squared. So they won't cancel out. So what I need to do is to have consistent units. So that would mean I need to make the 3 millimeters squared into meters squared. And how do I do that? So let's convert 3 millimeters squared down here. So I have 3 millimeters squared. I need to multiply that by some millimeters on the bottom to get that to cancel out. So just 1 millimeter for now. So there are 1,000 millimeters in 1 meter. That'll take care of 1 of the millimeters squared in the 3. So I need to do this again. 1,000 millimeters is for every 1 meter. That will convert it for us. Now, if you understand this concept, you don't need to go through this entire process. If you know that this equals 10 to the third, and this equals 10 to the third, then they combine to 10 to the sixth. So 1 over 10 to the sixth equals 10 to the negative 6. So I could just take this 10 to the negative 6 up here. So then the whole problem can just be 9 kilopascals times 3 millimeters squared times 10 to the negative 6. The negative 6 is just our conversion. It'll convert this into meters squared, and now we have consistent units. And that'll be our final answer. So the main point is to focus on whether or not we have consistent units. These are inconsistent units, so the math will not work out, and you will get a wrong answer and therefore lose points on homework, quiz, or exams. So what I recommend is to write out pascals like this to help you remember that it is meters squared on the bottom. Meters squared on the bottom. Therefore, multiplying it by millimeters squared will not work out.